Good morning, students. We have completed the classification of solids. There I have told you that on the basis of arrangement of particles, the solids are classified into two types: crystalline solids and amorphous solids. Crystalline solids have regular arrangement of particles. That's why they have well set geometrical shape, or they have a characteristic geometrical shape. While in amorphous solids, the arrangement of particles is not regular, or we can say particles are randomly arranged, so they don't have characteristic geometrical shape. Now, if we talk about crystalline solids where particles are regularly arranged, so when these particles shows repetition, then by this repetition we get a crystal lattice. So if we want to define crystal lattice, we can define it in two ways, both are same. First one, a crystal lattice is defined as the infinite array of atoms and molecules in space, such that at every point an atom or the molecule has got the identical surroundings. If we talk about metal gold or element gold, gold belongs to metallic solid, and metallic solid is a type of crystalline solids. So what is there in metal gold? In metal gold, there is repetition of gold atoms, and it contains infinite atoms. Each gold atom is surrounded by the gold atom at a fixed distance and in a proper number. And this is applicable for all the gold atoms which is present in the given gold matter. So we can use the term crystal lattice of gold because the provided metal part contains infinite atoms arranged in regular order. So here again the crystal lattice is defined as the infinite array of atoms and molecules in space such that at every point an atom or the molecule has got the identical surroundings. Or in other words, in a crystalline solid, the constituent particles, crystalline solid may contain atoms, ions or molecules. So in a crystalline solid, the constituent particles are arranged in a definite and regular order in space. The relative position of such particles in a crystal are shown by points. So the atoms which are arranged in gold can be represented by points. So these points represents atoms of the gold in crystal lattice of gold. The arrangement of these points in the crystal is called space lattice or crystal lattice. Hence, the crystal lattice can be defined as the regular 3D arrangement of the points in the crystal. So when these atoms shows repetition, definitely we will obtain 3D shape. So this 3D shape is called the crystal lattice. And the points which are showing repetition and giving rise to crystal lattice are called lattice points. Now then comes the next topic, that is your unit cell. Whenever we talk about crystal lattice, then this crystal lattice is repetition of unit cell. Unit cell on repetition will form crystal lattice or space lattice. Like if we talk about a room, then the smallest unit of the room is bricks. When bricks are placed together, we get a room. So in crystal lattice also, repetition of unit cell is there. Or we can say that it is the basic building blocks of crystal lattice. It is the smallest 3D entity that represents all the properties of the crystal lattice. Because crystal lattice is formed by the repetition of unit cell. So all the properties of this crystal lattice will be the properties of the unit cell. Unit cell, when repeated in different direction, generates the entire lattice. So by the repetition of the unit cell, we can get the crystal lattice. So unit cell is the smallest 3D representation of crystal lattice. Then comes the types of unit cell. So basically the unit cells are classified into 3 types. There are more also, but we are talking about the important one. First one is called simple cubic unit cell. It is the most primitive type. Also called primitive cubic unit cell. These points, all the lattice points are separated here so that we can visualize the structure. Otherwise they are compactly packed. So first one, in simple cubic unit cell, all the particles or the lattice points or the atoms are present at the corner of the cube. Cube is having 8 corners, so all the 8 corners we are having 8 particles or 8 atoms. Then we have body centered cubic unit cell. So here we are having the same arrangement, but with this, at the center of the body of the cube, we are having one more particle, one more atom or one more lattice point at the center of the body. Then comes your face centered cubic unit cell RCC, having arrangement of particles at the corner of the cube. With this, each cube is having 6 faces. At the center of each face, we are having atoms or the particles. So here we are having atom at first phase, then atom at second phase, atom at third phase, atom at fourth phase, and atom at sixth phase. Total 6 phases are there. One more is there here. So in FCC, face center cubic unit cell, we are having arrangement of atoms at the corner of the cube. With this, atoms are also present or the particles are also present at the center of the face. Now let us talk about rank of the unit cell. What do we mean by rank of the unit cell? The total number of particles or the total number of atoms present in a given unit cell is called rank of the unit cell. Now remember here, whenever we talk about corner of the cube, then from this point we can form 8 unit cell. So this point is a common point for 8 unit cell. from this point we can generate 8 unit cell. So whenever an atom is present at the corner of the cube, it contributes 1 by 8 to the particular unit cell. So here total we are having 8 atoms. Each atom is contributing 1 by 8 to the particular unit cell. So 8 into 1 by 8 gives you 1. So here in simple cubic unit cell, the rank of the unit cell is 1. Per unit cell we are having 1 particle, 1 atom. Then we have next one, body center cubic unit cell. Atom or the particle is present at the center of the cube, body center of the cube. It means it is a part of that unit cell only. So whenever a particle or atom is present at the body center, it contributes 1 to that unit cell. So here we are having 8 atoms at the corners, contributes 1 by 8. Total will be 1. 1 plus 1, it will be 2. So rank of the BCC is 2. We are having 2 particles per unit cell of BCC. Then if we talk about face center cubic unit cell, the atoms which are present at the center of the face contributes 1 by 2 to the particular unit cell. It means we can say a face is a common point for 2 unit cells. From here, from this face, we can have 1 more unit cell. So atom present here will contribute 1 by 2. So rank will be 1 by 8 into 8 from the corners is 1. Total 6 faces are there. Each contributes 1 by 2. 6 into 1 by 2 is 3. 3 plus 1 is 4. So here the rank of FCC unit cell is 4. So here rank is 1. Here rank is 2. Here rank is 4. So FCC unit cell is having maximum number of atom per unit cell. So this is all about crystal lattice and unit cell. Thank you and have a good day.